in the cloud. Let me give you the view of what's happening here. This is going to be this. Super, super. Now, okay, guys. Okay, good morning again, everyone. Sorry, I was a little bit busy in the beginning of the session to just write the success criteria of the course to post it on the website. I can see now that Mingji is here, Linda is here, Samantha is here, David is here, and Oliver is here. Good morning, everyone. And now let's start Monday with a very positive vibe. And the vibe is going to be the fact that just we are going to learn something new. And at the same time, I have a big surprise for you all. And the surprise is that we're just going to have a quick quiz today of the trigonometric identity after the break. Are you excited? Say yes, break quiz, huh? I can see Minji and Samantha, Linda, David, and Oliver are so excited for it. Okay. Okay, let's start. Today is gonna be the April 20th, huh? April 20th, and it's gonna be ADV, advanced function. Okay. Okay, now. Okay, guys, today we still continue with the trigonometric identities, but now we do something different. And the fact that it's going to be different is that if you give me 1 second, I bring my ruler. Okay. Guys, by the way, any questions from last week? Yes? Guys, please say your name if you're there.
Samantha.
Minji.
Okay.
Brian.
Okay.
David.
Okay. And who else? I know that Linda cannot talk because of the connection of the internet, but it seems that Oliver is maybe stepped away for a while. Okay, can you see this color, guys?
No. You know, I was not here on Friday. I have some personal things need to do, but like when I watched the video thing recorded, I couldn't really see on the screen. Like,
really?
Yeah.
Then it means that this is useless when I just record the stuff.
No. It just like used to, it's okay. Before it's okay, but this light is have some problem. I can't see it right now.
How about now?
No. Like,
how about now?
No.
No.
Even worse.
Even worse. Maybe that's because of the color. Let me change the color. How about now?
Still, like, okay, right now it's better. Yeah.
Oh, okay. Okay, because the color which I used, it was pink, and it seems that pink is not a good color to start the day with. Okay. Is it good now, Samantha?
Yes.
Awesome. And I expect that we catch up with the things which we had last week. We continue on that thing, huh? Awesome. Great. Okay, guys, the thing is that the purpose is that for the first half of the class, before we just start the break, then essentially afterwards, we are just going to have the quiz on the trigonometric identities. We are just going to work with one discipline. And the prescription for that is that we just start with a linear combination of some basic and fundamental trigonometric ratio, which is the basic as cosecant of the x and cotangent of the x, and we decide to build an identity out of it. And that's the purpose. In that case, we do not have an identity at hand, and we decide to verify that the identity is correct, which we did it since last week. We took either one side of the identity or both sides, then we try to just connect them together. But this stage is a little bit different. At this stage, we have the identity, we do not have the identity. We want to make up an identity. That's the plan. That's the learning goal for today. For example, I have written two basic trigonometric ratios, which I know what is a cosecant and I know what is a cotangent. That's right. And the process is going to be very easy. The process is going to be very easy. I know beforehand that what is the cosecant as a ratio of cosecant of the x. Okay, Brian, are you there?
Yeah.
What is cosecant of the x?
Cosecant, cosecant 1 over sine.
Fantastic, fantastic, thanks. Cosecant is 1 over the sine of x. Guys, do you see this color?
No.
No. How about now? Is it good?
Better.
There, awesome. We say that, as also Brian said that, it's the cosecant of the x is a fundamental trigonometric ratio, which is essentially the inverse of the sine x. I have cosecant, I rewrite it as, for example, the other notation, which is 1 plus sine x. Then for the next stage, and what is a cotangent? I should say, ask Samantha.
Cotangent is one.
Cotangent. Cotangent.
1 over tangent.
And or also, we have two identities for it. That's great. The first one which you came with.
I don't know then.
You mean the cosine over the sine, huh?
Oh, okay.
It was another definition of the cotangent. Then what do I do here? I simply rewrite my ratios which I had, and I come to do what? And I come to just rewrite them and then just simplify them. In order to do that, I have now two ratios. I have 1 over sine x. I have cosine x over sine x. Then the thing which needs to be done, if they are summed up, I have to just take a common, I should say denominator, which is going to be the sine of the x. Then I have sine x plus cosine x times sine x. Correct?
Yes. Hey, Aria want me to ask you, like, she's like really sick today. Can she do the quiz tomorrow or so?
I don't know. I would tell you a little bit later because I don't know if you should have a makeup quiz then.
Yeah. No problem.
Thanks.
Just
Thank
wanted
you.
Yeah.
Okay. Look at these guys. Then. Oh, what did I do? Oh my God! I made a horrible mistake. It is not correct. Sorry, guys. It is not correct because because the common denominator is sine of the x, and they keep the sine of the x there, and it becomes 1 plus cosine x. Okay. then because when I just rewrite my trigonometric ratio, then I end up with this case then. Then you will see that as a result, at the end, I constructed a new identity. And my identity is this, that I can write the cosecant of the x plus cotangent of the x is essentially this one. 1 plus cosine x over sine x. Then you see that how easily I was able to just reconstruct a trigonometric identity, which I can also go backwards to prove it. Okay, guys, you will see that I started with two trigonometric ratio. I build up an identity myself right now here. And it says that the cosecant of the x plus cotangent of the x is 1 plus cosine x divided by the sine x. And now by nature, it is an identity itself. Then you can have lots of fun. Just start with any trigonometric ratio and expand it and create an identity. And for example, it was the first example which we had. Any questions, guys, on this?
No.
Nope. Let's
No.
move on to the second example. Okay, for the second example, I have this one. I have 2 tangent x times secant x. Guys, I just gave you these two basic fundamental trigonometric ratio. You please just work on your own for 1 minute to see what kind of an identity you can make. Yes, Mingjae?
Yes.
Good morning, Sean.
Good morning, good morning. Beautiful day, huh?
Oh my God, Monday
Yeah.
is the best day of the week.
That's so
Crazy
right.
about that.
Especially studying some trigonometry.
Oh my God, I'm so pleased that I hear that from you. Sean, I have a quick, I should say, a very, for you and the people who has done, I should say, programming here at the school, the next assignment, I'm just gonna, as I said, I just gonna post that on the website for CSAL, Science Club. You can use that concept which models the action potential of a single neuron in the brain. You can use programming to simulate it, and it becomes super interesting.
Really? Is that
That's
hard?
right, for you and anybody else who's doing programming then. For Brian, Ningjae, Samantha, David, Oliver, and all of you then. Then it's gonna be an interesting exercise then. You model a single cell in the brain using the math, then using the programming to simulate it. It's super cool. Okay, guys, anybody got the identity?
Is 2 tangent
X secant x. Minjay, did you got the identity?
Yes.
Now, what is that?
2 sine x over cosine x square.
That's right. But can you continue that further?
This
Let
is
me
my
do it now.
final answer.
That's right. You just started very strong and very good. Guys, look at that. What I'm going to do. The fact is that you strip, the basic principle is that, guys, if you remember, we had 6 identities. 2 of them was very fundamental. I mean, in terms of the sine x and cosine x, they were essentially very fundamental. You cannot rewrite them in a simpler form. But the other four identities that we started with, like the tangent, cotangent, secant, and cosecant, you can always rewrite them in terms of the sine and cosine. And that's the beauty of the sine and cosine ratios, because they are like the building blocks of any trigonometric ratio and identities. And the secant, cosecant, tangent, and cotangent, at the end of the day, they can be re-expressed in terms of those fundamental identities. In a sense, as also Mingje said, in terms of the tangent, I can rewrite it in terms of what? In terms of the sine of the x over cosine of the x, because this is one of the identities that we learn. But at the same time, I can rewrite the secant of the x in terms of what? In terms of, David, what is secant of the x?
1 over cosine.
Thanks, David.
No, I'm just saying.
Yeah, that's right. I'm kidding. I'm joking around. I'm always on a very good mood on Mondays. Then I make too much jokes. Just on Mondays, not on Friday.
Why
Friday
not?
we have the surprise.
Hey.
What, Sean?
On Friday we have the surprise. Someone will do the speech.
Oh yeah. She got the admission to one of the most competitive program in the whole Canada.
Yep.
It requires an average of 96. It's super.
Super.
That's right. And now, I just got to this stage, and I think it was Mingje. He just came with an interesting idea. Then Mingje said that, Mingje, what did you do here?
The common denominator is cosine x, so they times together is cosine square x.
That's right.
2 times sine x times 1 is the I don't know.
That's so true.
Yeah,
That's so
that's it.
true. Thanks, Mingje. Fantastic. But by the way, can you see this color, hopefully?
Yeah.
Awesome. And now, did you stop there, Mingje, or did you continue further?
I stopped there, but the cosine square x I can write in 1 minus sine square x.
That's so true, because it makes the identity looks much better, because we try to use as many identities as we can. Then essentially it turns out to be what? Turns out to be the 2 sine x divided by minus 1 sine squared of the x, because we know what? Previously, we learned this identity that the sine squared of the x plus cosine squared of the x equals to 1. It is identity number 5, I should say, the most important identity and one of the most fundamental ones. Then essentially, as you will see, I can rewrite these expressions like this. I can write 2 tangent x secant x equals to what? 2 sine x 1 minus sine squared x, right? It's going to be page number 2. And now you see that, guys, you build up this very beautiful, good-looking identity. This is a very good-looking identity that we can also prove this. If you have it on the test, in order to prove this, what do you do? I'm going to ask it from Sean. Sean, when you have this identity, when you start from this How do you prove this? You made it. You built up this identity yourself, but how do you prove it?
Left side equals to right side.
That's right. How do you start to show that identity, to verify that?
First, we only see one side and get the same equation to the right side.
That's right. From here, what do you do? What do you recommend to do in order to prove itself, to verify this identity itself?
Prove this. Start from the left side.
You mean from 2 tangent secant x?
Yeah.
Then how do you proceed?
So it's it should be written down to see.
No worries. But in order to proceed, guys, you have to rewrite it back again to move these steps back. You can just start from the right. You say 1 minus sine squares of the x becomes cosine squares of the x. Then say 2 sine x divided by cosine times 1 over cosine. You take all the steps you have taken backwards. Then in that case, you can verify this identity itself. Okay? Any questions, guys? Things seems very neat, huh? Okay.
Here's my problem. I can't like really recognize like things like tangent equals to sine x over cosine x. That's my problem. I can't like really identify them when I doing the questions. Do you have anything like a list about all of the identity of the trigonometries?
Yeah, we had it, I should say, let me find it. We had it, I should say, on Wednesday. We do not, just Samantha,
Yeah.
the list for trigonometric identities is inexhaustible because you can have over thousands of the identities. You see, we create an identity, huh? But if you have 6 identities, but I think it was last Sunday, we had, no, not Sunday, I think last Tuesday, I'm just going to rewrite it again. We had 6 identities. Give me a second, I find it. Oh, I was so lucky I found these ones. Do you remember this page? We had it on Monday, last Tuesday. It was on, let me check the date.
Actually, I have the note.
And that's all that we need. Look at that, Samantha. We have 6 identities.
Okay, hold
2 of them is the most fundamental one. Sine x and cosine x, we showed them on the unit circle. And also about tangent x and cotangent x, which is these identities. Tangent is sine alpha over cosine alpha. And cotangent is cosine alpha divided by sine alpha.
Wait, hold on. Could you move your finger, please? I want to take a picture. Thank you very much. There we
No
go.
worries. And we also had cosecant alpha and secant alpha, which are the inverse of these two.
Okay, yeah, I got it.
It brings the number of the ratios which you have to 6. These are 6 fundamental, I should say, ratios. Sine x, cosine x, tangent x, cotangent x, secant x, cosecant x. 2 of them, which is sine and cosine, they are the building blocks. The others are built up on them. And at the same time, we discussed 2 identities, the 2 most fundamental ones, that the sine squared of the x plus cosine squared of the x equals to 1. And also tangent x times cotangent x also equals to 1. Huh?
Okay.
That's right. And from these are all the things which you need, Samantha, for all identity verification. And the rest of it, it is all the things built up on these ones.
Okay.
You do not need to memorize the identities. You need to only know 6 ratios, and the rest is going to be very easy.
Okay.
Yeah?
Yeah, now I got it.
Awesome. and also at the same time, as you mentioned it yourself at the beginning, the tangent alpha and cotangent alpha are, I should say, they are the inverse function, and that is why their multiplication reaches to 1. Good?
Good.
Awesome. Okay, let's do one more example, then we get ready for the quiz for the identities. Okay, I'm just going to give you this identity. Which is going to be the cosine x one plus secant of the x equals to 1 minus cosine x tangent the square root of the x. Okay, guys, as a kind of a warm-up for the today's quiz, I have given you this identity. Please verify that. Everyone can see what I have written?
Wait.
This is cosine x over 1 plus secant of the x equals to 1 minus cosine x over tangent the square root of the x. Guys, please let me know when you're done. Okay, so who's done? Guys, anyone is done? Hello? It means nobody's done, huh?
Yeah.
Samantha, you're done? Mingje, Sean, Oliver, Brian, David?
No finish, teacher.
Ah, okay. Oh, Linda. Oh, good. No worries.
Okay, okay.
Thanks. Guys, if you don't mind, just to start, and you please just continue with me. Okay. Okay. Guys, in order to, but anybody, before I start, anybody finish this to show me the result? No?
I'm finished.
Oh, you're finished. Fantastic. Fantastic. And guys, look at that. Thanks, Mirjay. Did you start from the left or did you start from the right?
I proved both sides.
Both. Ah, you just start from both sides. You reach the same
yeah.
one, huh? Okay.
Yeah.
Thanks. Guys, look at that. In order to show this identity, I'm just gonna do something creative. You can just come with many other ways to prove it, but this one I'm gonna start with a method which seems more creative and a bit harder, just for the sake that you see different kind of methods. But of course, you can come up with easier methods to prove this identity. And the method which I just want to use to prove this identity is built on this fact that you know that, guys, based on the things that we have learned, if you have, let me write it here first before I continue. You have learned it, guys, that if A is one expression for you, you can multiply that to B over B, which is still you get the same argument A. This is the thing which you have seen in the algebra. It means that you can, whatever algebraic expression you have, you can multiply that to a ratio which its numerator and denominator are the same. Then essentially when the ratio is built, because B and B are the same in terms of the magnitude, it's essentially 1, which it means essentially you are multiplying your expression A into number 1, which is A itself. Then essentially means that the ratio B over B is doing nothing and keeps the magnitude of your expression intact. I'm gonna do the same thing, but I'm just gonna start from the left side in order to prove this identity and use the concepts of the conjugate to prove this identity. What do I mean? I mean that I start from the left It means that I start from the left, which I have what here? What is my expression on the left side? It is cosine x divided by 1 plus secant of the x. Okay, that's the identity that we have, but from the left side. As I said, I'm just going to do something creative just for the sake that you see different methods, but you can just do something different. What I'm going to do here is that I'm going to multiply this into the conjugate of the denominator. What is my denominator here, guys?
1 plus is a second x.
Secant of the x, that's right. That's my denominator. You have seen that, or I should say in the beginning of the term, and you have seen in the functions 11, that there is a concept which is called the conjugate of an expression. It means that if a plus b is an expression, in order to make its conjugate, you simply write it as a minus b, correct? Then as a result, what do you do is this. Then you write what? You write, I'm just gonna multiply the left side of my identity on a ratio which its numerator and denominator are the conjugate of the left side, which is gonna be 1 minus secant of the x, and it's come 1 minus secant of the x, right? Correct, guys?
Correct.
Then I didn't do anything except I multiplied my left side of the identity to 1, which this one is decomposed in terms of 1 minus sine x divided by 1 minus sine x, secant of the x, which is the complex, which is the conjugate of the denominator. Okay. What is going to be the result? At the denominator, I have what?
So multiply by 1.
That's right. Becomes 1 minus secant squared of the x, because you remember it from the function 11 that a minus b times a plus b becomes a squared minus b squared. A is here 1, b is secant squared, then a squared, which is 1, 1 squared, which is 1, and secant squared, which is secant squared, I have it there. And at the same time, I know that I have to multiply the numerator to each other, which it becomes, in this case, it becomes very easy because you know that a cosecant has to be multiplied to 1, and at the same time, cosecant is multiplied to the secant of the x, which I get cosine x minus cosine x times secant of the x. Everyone is here with me so far?
Yes.
Okay. Hold on a second, please. Okay. And now I have this one, but in order to proceed, look at this expression, guys. Cosine x times secant of the x. What is that? How much is that going to be?
Wait, don't say it. Don't say it. Don't say it.
I'm going to...
Wait. Cosine secant. Wait. Oh, okay. I don't know. Okay, never mind. I don't know.
No worries, Samantha. Secant of the x is what? Is 1 over cosine of the x.
Oh,
Then
okay.
essentially you're multiplying cosine of the x to 1 over cosine of the x, which becomes what? 1, huh?
Wait.
Look at that.
How do you get this? Wait.
Cosine x times secant of the x, it's equal cosine x times 1 over cosine x. You see that?
Yes.
Then cosine x, 1 times cosine x becomes what?
Oh, 1. I'm just wondering why there's no cosine x over cosine x equals to 1.
That's right, no worries. Then Then as a result, I'm just going to write to a conclusion that this one becomes what? Becomes cosine x, which is left from the first term, minus 1 divided by 1 minus secant squared of the x. Correct? And now, we had an expression before, we had an identity before of this area. We had what?
We have secant square x equals to 1 plus tangent square x.
We had what?
Secant square x equals to 1 plus tangent square x.
That's impressive. Thanks, Samantha. We had this identity before, that 1 plus tangent squared of the x is secant squared of the x, and we were able to show this identity and verify that. It was very simple. You can write tangent squared as sine squared divided by cosine squared. Then you end up with 1 over cosecant of the squared. Then becomes the secant squared. And now look at that. I have this one. 1 minus secant squared of the x. In order to find this, I'm going to milk it. I'm going to keep 1 here. And I have take the secant to the other side. Secant squared of the x becomes what? And I take the tangent to the other side, minus tangent squared of the x, correct? Then as a result, I can write this one like this, that it becomes 1 cosine x minus 1 over minus tangent of the x, tangent squared of the x. Guys, are you okay so far?
Yeah.
Yeah. Then we had secant squared of the x equals 1 plus tangent squared of the x. That's the identity we verified before. But on the top, I have 1 minus secant squared of the x, which it means that if you just rearrange the terms on both sides, for the 1 minus secant squared of the x, due to this identity, you can have it minus tangent squared of the x. Then please compare this term to the term on the top. The right side of the identity.
Yeah.
I have 1 minus left. I do not have a minus there. Then it means that I divide. I can just factor minus from the tangent, becomes tangent squared of the x, and take this minus sign.
Wait. What did you do? Wait, where is the minus thing came from? Oh, okay.
I take this minus sign to the top. Because it doesn't matter, I can do that. If I do that, minus 1 becomes plus 1, and cosine becomes minus cosine x. Yes, Samantha?
Yes. Wait, hold on 1 minute. I'm just like need to.
Yeah, please, right there. Let me ask the others. David, Linda, Brian, Minjay.
Okay, teacher.
Guys, any questions? Did you get what happened?
Maybe.
Do you want me to re-explain it once more?
Yes.
Sure. Guys, I'm going to explain it once more. Please hold on with me. Minjay, did you do the same method or you did it something different?
I proved both sides and get the same result.
You just expanded from both sides.
Yeah.
Okay. Yeah, that's a reasonable thing. This one, guys, it was a little bit harder, but I just wanted to show a method to you that you may use that on future questions. The thing that we did was this. We said that, Linda, everyone, ready? I'm going to say that again. Samantha, Brian, David, Linda. I said that I look at the left side of my identity. I'm just going to play around with that term only, and I just keep the right sides intact. I'm not gonna change it. Then as a result, my strategy for this one is that I'm just gonna move from the left side to reach to the right side and say, okay, after taking some steps, I was able to get to the right side. Then by doing that, I verified this identity because, you know, it was one of the strategy. In order to do that, on the left side, I multiply both sides to the conjugate of the left side, which is going to be the conjugate of the denominator, but keeping in mind that the ratio has to be 1 is 1 minus secant x times 1 minus secant x. This whole expression guys, this whole expression has nothing to do because the whole expression here essentially is 1. And it doesn't matter if you multiply that. But if I multiply that to this expression, I get denominator 1 minus secant squared of the x. And at the numerator, I have cosine x minus cosine x secant x. Guys, everyone is good so far? So far, so good?
Yes.
Yes.
Yes, nice. And now I look at the second term at the numerator. I have cosine x times the secant of the x. For this one, guys, I know that the cosine of the x and secant of the x, if they get multiplied, they should be equal to 1 because I know that the cosine times secant is cosine divided over 1 over cosine x, which these cosine, they vanish and I'm left with 1. Then as a result, I come to this line. Then I have cosine x minus 1 divided the same denominator, 1 minus secant squared of the x. Okay?
Mm-hmm.
Previously, we had this identity that secant squared of the x plus equals to 1 plus tangent squared of the x. If you rearrange the terms, you get 1 minus secant of the x equals to tangent squared of the x minus. But if you do not remember this identity, you can show that yourself. You ask yourself, sorry, I'm just gonna, let me finish this, then I show that what happens. Then you put that inside the argument there, then 1 minus secant squared of the x becomes minus tangent squared of the x. Then you take minus up there, becomes 1 minus cosine x divided by tangent squared of the x, which is essentially the same thing which we had on the right. So far, so good, guys?
Yes.
Yes.
But
Yes.
if you sometimes wonder that, where did I get the identity that the secant squared of the x equals 1 plus tangent squared of the x, you may ask yourself, I may not remember this identity. Then what should I do? I just come here of 1 minus secant squared of the x. I want to see if I can make this identity myself or not. If I write here, everyone can see that? Yes?
Yes.
I write 1 minus secant squared of the x equals to what? 1 minus, what is the definition of the secant squared? 1 cosine x, huh? That's right. Cosine squared of the x. Correct, guys?
Wait, I can't see.
Oh, you cannot see that, huh?
Oh, I can.
Okay.
Now I can. Yeah. Okay.
Then I'm just gonna start with this one, guys. Look at this term. One minus secant squared of the x, which it was at the denominator of my term there, I'm gonna write it as 1 minus secant squared of the x equals to 1 minus 1 over cosine squared of the x. Then Samantha, Linda, David, Brian, Oliver, Sean, and Ninja, you see that if you know just only 6 trigonometric ratio, it's always very easy to build up, I should say, the identities. Because I know that the secant squared is 1 over cosine squared of the x. Then what happens now, I'm just gonna take the common denominator. I have the cosine squared of the x. I have the cosine squared of the x minus 1, correct?
Correct.
That's right. Okay, but what is that? I have cosine squared of the x minus 1.
Cosine squared minus
Look
1.
at this identity. We proved it. We said that it's always valid. Cosine squared plus sine squared is always equals to 1. Huh?
Yes.
Then, as a result, cosine x minus 1 becomes minus sine x.
Oh, minus sine x.
That's right. Then what do I have then? Then I can substitute, it becomes minus sine x divided, sine squared of the x divided by cosine squared of the x, which is what? Minus tangent squared of the x, which we got it back there again.
Okay.
Any questions, guys?
No, I think I got it.
You got it? Mingxi,
Yeah.
Brian,
Yeah.
do you have any questions?
No.
David? Linda?
No.
Are you fine? You got it?
Yes. Yes.
Fantastic. How about you, Oliver? Okay. What time is it now, guys?
9:58.
9:58. It just seems that we are close to the break. Guys, I think the best thing we can do is that I think it's a good time to take the break, huh?
Mm-hmm.
And I think it's good to just take the quiz tomorrow, huh?
Okay,
You
thank
do
you.
some more practices, then when we come back from the break, we take some a new lesson and 2 more identities. We talk about the sum formula, then we take the quiz for tomorrow.
Yeah.
Good?
That would be great.
Everyone
Yeah.
is good? Everyone feels okay about if you take the quiz tomorrow?
Yes, perfect.
Yeah? Okay. Oh, sorry, guys. I just wanted to have a good surprise for you today, but it seems that it's not going to work. We're going to have the quiz tomorrow. Okay. Then please, guys, take 15 minutes break. Please come back by 10:15. Then we continue from there. Okay.
Okay.
Awesome. Awesome. See you guys then. See you in 15 minutes.
Yeah, see ya.
Thanks. Bye. Hello. Hello, guys. Are you back?
Yes.
Guys, unfortunately, I have to make a change of the plans. And that is, I checked the schedule which we have. We cannot continue any more exercise on the identities because we have to move on to new topics. Then we have to take the quiz right now, unfortunately, because tomorrow it's not going to be enough time.
I'm so dead.
Sorry, what?
I should use this time to review. I didn't review. Oh my god.
Yes.
No worries, 15 minutes. Now you can also, that's the exam. It's a kind of an open book. It's, I tried to scan the documents which I had for the quiz, which is this one, but it seems that from the app which I scanned it to send it to you, it takes forever. And then I have to write it here on the paper. Then you just they do that on your papers then. Guys, this quiz has 4 questions. Sorry, guys, everyone is here. Please say your name.
Samantha.
Brian.
Minji.
Anyone else? Sean is also here. How about Linda? Okay, we have 4 questions for the quiz. The first question is this. Please, you also write with me. It's gonna be the identity, which is tangent of the x plus
Okay.
cotangent of the x equals to secant of the x multiplied to cosecant of the x. That's the first identity. Then it becomes tangent of the x plus cotangent of the x equals to secant of the x multiplied to cosecant of the x. The other one is this. 1 minus sine x divided by cosine x equals to cosine x plus divided by 1 plus sine x. The third one is gonna be cosine x minus sine x divided by minus 1 tangent of the x cosine x plus sine x 1 plus tangent of the x. And the last one cotangent of the x cotangent of the x plus tan x equals 1 minus sine squared of the x. And that's it. Guys, everyone got these questions?
I can't see the second one clearly.
You mean this one?
Yeah.
This is 1 minus sine x divided by cosine x equals to cosine x divided by 1 plus sine x.
Yeah, I see. Thank you.
No problem. Guys, any questions? Do you see everything clearly?
The cosecant x is cosec.
Oh, sorry, it's C. I should have just put O. This is CSC.
Okay.
CSCX.
You scared me. You freaked me out. I was like, oh my god.
Sorry about that. Then you see the rest of it clearly, huh?
The second one is 1 minus sine x, right?
That's right. I'm gonna reread it from the beginning. The first one is that tangent x plus cotangent x equals to secant x times cosecant x.
Okay.
The second one is that 1 minus sine x divided by cosine x equals to cosine x divided by 1 plus sine x. The third one is cosine x minus sine x divided by 1 minus tangent x equals to cosine x plus sine x divided by 1 plus tangent x. And the last one is that cotangent x divided by cotangent x plus tangent x equals 1 minus sine squared of the x. Everyone is fine now?
Mm.
Linda, did you write it? Linda? Ningji?
Yeah.
You write everything?
Yeah.
Awesome. How about you, Brian?
Yeah.
You're fine?
Yes.
Thanks. David, how about you? David? How about Oliver? Sean, are you okay? Sean? Oh, he cannot hear me. Okay, guys, you have until 11 to finish the test.
Hi, sir. Hi, sir. Hi, teacher.
Hello, Arya.
Hi, teacher.
Hi.
I'm sorry, can I have the quiz?
Yeah, sure. Give me 1 second. I couldn't email it. I have to show that paper to you. Then I'm just gonna put my laptop upside down.
Oh, so, can I find it on Schoology?
Unfortunately, I scanned it to myself, but the problem is that they take so much time to just get the quiz to the Schoology then
Okay.
you have to write it, please.
Thank you.
No worries. Do you see that? Do you need me to read that for you?
Huh?
Do you want me to read that for you?
Oh, I need to write down.
Yeah. Do you want me to read that or you can see that clearly?
Um, um, can you move? Can you move to right?
Is it good now?
Uh, um, and can you move a little bit closer?
Sorry, what?
Closer.
Sorry, I cannot hear you. Are you?
Huh?
Sorry, say
That's
that
okay.
again.
That's okay, teacher.
That's okay. Please read the whole questions. Please write the whole question first because I just want to remove my laptop from it.
So there are 4 questions in
That's
this
right.
quiz.
2 identities to verify them.
Okay, thank you.
No problem. Hmm. Okay, are you done or can I just remove my laptop from it?
Sir, how to submit the answer?
Oh, please email it to me through the Schoology then.
I'm done, teacher. Sorry.
Oh,
I
okay,
forgot
no
to tell
worries.
you.
Yeah, because I'm assigning the new homework, then I'm just gonna write it down there. Huh.
Oh, thank you.
No worries. Good luck, Arya.
Okay, thank you.
No problem. Okay, guys, are you done?
Yes, teacher.
You're done, Linda?
Yes.
Fantastic, fantastic. Please submit it to me on the Schoology email. Please do not submit that to my personal email, because when the inspector comes and they see that there is no work for you on the Schoology website, I get fired. Then please email it to me on the Schoology website.
Okay.
And if you haven't done yet, please, you have still 15 minutes to work on it. But for those people who are done, and if you are doing, just please listen to me. I posted a homework for you, which the deadline for that is next Monday midnight. And this is called the model of the Hodgkin. Oh my God, I always have some difficulty to pronounce that. Hodgkin-Huxley model of the brain. You have to write your report for 800 words to the online resources, for example, from the Wikipedia and some other resources, not to produce the math, but in order to familiarize yourself that how the mathematics can be used to describe the function of the brain. That model in the math, it won the Nobel Prize in physiology a couple of years ago. It is one of the most accurate mathematical models which describes the function of the brain. It won the Nobel Prize. Then you write 800 words on that, and you have to post it on the Science Club, your understanding of what is that. It has to be 800 words. And if you are able also to use the codes for people who has done the computer science or programming, I'm gonna write the code myself to simulate that model. Then you simulate to see how the brain works. And based on the math, and the computer programs coming from it. It comprises 10% of your final mark, depending on the quality of your work which you do. But as I said, you do not have to do the math. You have to see how math is used to describe the brain. Then that's for the homework for the next weekend. Then good luck with the rest of your study. And if you're not done with the quiz, you still have 15 minutes left.
Okay.
So teacher,
Yes.
so the assignment that you said, how to say that? The information is in Schoology. Can I
That's
find
right.
it?
About that assignment, I posted all the details of what needs to be done on the Schoology website there. And
But
also for Aria and Samantha, you haven't yet enrolled in, and David also, you haven't enrolled yet into the science club. I have sent a notice on Friday with the step-by-step instruction how to get enrolled into that website then. Please read that and do that and enroll yourself there.
so teacher, I didn't find the assignment in Schoology.
Sorry, what?
I didn't find this assignment.
This is on the notice update.
Notice.
I posted it right now.
Mm,
It is dated for April 16. And guys, please also remember, tomorrow is a very important day for two reasons. One of them is a lesson. There should be no one absent tomorrow. If anyone is absent, it's gonna be very bad. I'm gonna deduce mark from you. And the second thing, guys, if anytime you are gonna have a guest speaker, you have to have your camera on because of the respect to show that for the guest speaker there. These are two things I just wanted to mention.
okay.
And please make sure nobody should be absent tomorrow or late. Please
Okay.
be sharp on time. No absence, not being late. And please continue with the quiz then. I talked too much. I distracted you guys very much. Sorry about that. You can continue your quiz then. Okay, I'm gonna. Who is done with the quiz? Please
Teacher.
remember, you have to submit it to me by 11 a.m.
Teacher, I don't know how to send it to you. This quiz.
Okay, give me a second. How did you send it to me, your midterm then?
Yes.
Let me give me a second. Okay, Linda, I sent you a message on the Schoology, okay, Reply back to that message and attach your file. Okay?
Okay,
Thank you. And I do the attendance. It's gonna be,
Teacher,
yes.
what the name of the assignment? Can you tell me?
The assignment I posted there, it's the very last one. I just posted 5 minutes ago.
But I didn't find. I didn't find it. I don't know why.
You did what?
I didn't. I cannot see that. I don't know why.
It's yeah, refresh your page. Maybe you have to refresh your page.
Okay.
Thank you. Let me read the names. Guys, who is Dai Wei? You have no Dai Wei. Who is, okay. Lead one is Samantha, huh?
what is the last name?
Fang,
Yes.
yeah. Mingzhi is present. Yutian Lee, this is Linda, huh?
No, teacher. It's Aria.
Ah, it's Area. Thank you. And Yudon Linda, huh?
Yeah,
Okay.
maybe you can hear her. Yes.
Yeah, Henry is absent. Mary, Aries. Brian is here. David is here or no?
Yeah, I'm here.
David, what is your Chinese name?
David.
Ah, okay, you are here. Okay. Where is Oliver? Oliver? I think the app is on, but it seems that I'm gonna put him as a absent in case if I did not even get the.
What's awesome?
Sean is here. Okay, Brian is here. I saved the changes. Guys, we are getting almost close to the end of the session for today. Please remember to submit your assignment to me before 11:10, before you go to the next class. And also, that's pretty much everything. And please check on the Schoology website for, I should say, your model for the Hodgkin-Huxley. It's going to be due by next Sunday midnight. And please remember, guys, no absence for tomorrow, and please be sharp on time, because also the lesson is very important. The lesson that we're going to learn, and we may have a guest speakers, and also anytime if you have a guest speakers, please remember you have to have your camera on, and that's very important. And that's pretty much everything. And any questions, guys?
No.
No? Then please submit your homework to me, submit your quiz to me by 11:10. And I see you all tomorrow then, sharp by 9 a.m. Okay. And also, please, guys, start working on the assignment which is due for next week. This is very important. And have a nice day, guys. And enjoy the rest of the Monday. See you all tomorrow, sharp 9 a.m.
Bye.
Bye, everyone.
Bye.
Goodbye.
Bye. Have a good day.
Bye, Sean. Bye, Mingji. Bye,
Bye.
Oliver. Bye, Linda. Bye, Brian.
Teacher,
Bye,
I
baby.
don't know how to send into you my homework.
Linda, did you get an email from me on the Schoology?
I don't know how to use Schoology email.
Can you email it to my personal email?
Yes.
Okay, that's fine then.
Oh, so difficult.
Oh, no worries.
Because
Send it to me. Yeah, send it to me on my personal email.
Okay.
Awesome, awesome. Is it good, Linda?
Yes, I finish assignment today.
Fantastic, fantastic. Thank you. Then please email it to me and I see you, Linda, tomorrow, huh?
Okay.
Awesome.
Bye,
Have a nice
teacher.
day. Have a good day. Bye. Bye, Linda. Bye, Brian.
Bye.
See you tomorrow.